Basically, we're looking to establish carbon electronics as a primary center of excellence here at NC State. Carbon electronics is basically things like organic LEDs that you have on your iPhones and smartphones and your high-end TVs, but it can be used in many environments. The important part for you as a student potentially joining us here would be to understand that this is an interdisciplinary environment that includes the departments of physics, chemistry, material science, electrical engineering, and many other things.
What's really special in ORaCEL is the fact that students can get many different perspectives on the field of organic electronics. And so in my group, we're mostly interested in really basic questions, like, for example, if you've got a disordered, almost amorphous organic solid, what's the shape of the density of electronic states? And that's a really sort of a pure question that doesn't have immediate impacts on industrial applications or anything like that. But even students working in my group who are participating in our really pure science projects can also pursue much more applied work for their own thesis, because we have the infrastructure here to let them go to other labs, use other facilities, and sort of build a custom thesis that includes both pure and applied aspects.
What I really enjoy is the collaborative environment and the interactions that we get to have between different people in the various groups. As a theory group, it is invaluable to talk to our experimental colleagues on a regular basis. This way everyone gets a chance to learn from each other and work together on collaborative projects.
My research interests are in understanding the properties of materials at the atomic scale. And at NC State, we have access to a wide range of state-of-the-art facilities for probing the properties of materials at the atomic scale. We also have access to state-of-the-art facilities at national labs across the country, which allow us to probe how materials behave from the atomic scale upwards.
My group expertise is in very sophisticated ultrafast nonlinear optical spectroscopy tools. Our goal is to understand fundamental and practically important dynamics. For instance, we study extended quantum coherence in semiconductors or macroscopic quantum phase transitions, which are important for emerging quantum information technologies. These studies require access to new exciting materials. In ORaCEL, we work in close collaboration with faculty from material science and engineering, chemistry, and physics in this strong collaborative environment of ORaCEL.
Collaborations between the physics department and other research group in material science and the mechanical engineering department is one of the important aspects of working in ORaCEL. My research group provides expertise and instrumentations in magnetotransport and spintronics to collaborate with the Amassian's group in MSE, the Lewis group in MAE, and several other groups. This not only brings in diverse ideas and capabilities, but also expand the scope of the impact that we have and the type of funding that we can seek.
Being a part of the ORaCEL group as a PhD student gives me the possibility to work in a very collaborative environment. I have the possibility working with professors from material science and engineering department, from chemistry, from physics department, of course, and that gives me access working with different material systems, develops my expertise, and gives me new perspectives.
And so we provide a special environment here, not only in terms of interactions and the science, we also have shared facilities, and that allows you to get a skill set across many kinds of tools.